Let me ask you something that might genuinely make you rethink everything you know about the tech industry. What if the biggest takeover in computing history was already happening, right now, at this very moment, and the way we've been measuring it has been completely, fundamentally wrong? Because here's the thing, every time someone says Linux is winning, there's always that one guy in the comments who fires back with the same line. Bro, Linux has like 3% market share on the desktop. It's irrelevant. And look, I get it. On the surface, that number sounds damning. It sounds like the argument is over before it even starts. But what if that number, that single lonely desktop market share percentage, is the most misleading data point in the entire technology industry? What if we've been staring so hard at one tiny corner of the map that we completely missed the continent that Linux already owns? That's exactly what we're going to break down today. And by the time we're done, I promise you, whether you're a Windows loyalist, a Mac person, or someone who's never touched a Linux terminal in your life, you're going to walk away seeing the computing world in a completely different way. Let's start with the core problem. The desktop market share metric was born in an era when the desktop was computing. Back when Windows ruled and the PC was the center of the digital universe, measuring desktop share made perfect sense. It was like measuring ocean coverage by looking at the Atlantic. Sure, you're not seeing the whole picture, but the Atlantic is so dominant that it's a reasonable proxy. That logic worked in 1995. It worked in 2000. It even kind of worked in 2005. But computing didn't stay on the desktop. It exploded. It went into data centers, into smartphones, into cars, into hospitals, into classrooms, into spacecraft. The computing landscape became this massive, multi-dimensional ecosystem stretching across a dozen different industries, and the old desktop metric just didn't follow it. It stayed behind, measuring a territory that's becoming less and less representative of where computing actually lives. So when someone uses desktop market share to dismiss Linux, what they're really doing is using a map from 1998 to navigate a world that was completely rebuilt. And the honest truth is, Linux didn't lose that territory. Linux built the new world. Here's where it gets genuinely fascinating. Let's talk about gaming, because if there's one domain where people assumed Linux would never crack through, it was gaming. For years, the gaming world on Linux was a passion project. Enthusiasts fighting compatibility layers, community workarounds for DirectX games, anti-cheat software that outright refused to run on anything but Windows. Linux gaming had heart, but it had walls too. Then in 2022, Valve dropped the Steam Deck, and everything changed. The Steam Deck isn't just a handheld gaming console. It's a Linux computer that runs in your hands. It ships with Steam OS, which is built directly on Linux, and it introduced something called Proton, a compatibility layer that lets Windows games run on Linux with shockingly good performance. And here's what made the industry pay attention. It actually worked. Not in a good enough for tinkerers way. In a I played Elden Ring on a plane for 6 hours kind of way. The commercial success of the Steam Deck forced game developers to confront a reality they'd been ignoring. Suddenly, there's a significant growing installed base of Linux-powered gaming hardware, and those players are spending real money. So Valve rolled out Steam Deck Verified, a certification process where developers test and confirm their games run properly on Steam OS. And developers actually did it, not all of them, but enough that the Steam library's Linux compatibility went from a niche curiosity to a mainstream reality. What this creates is a feedback loop. More Linux-compatible games mean a more attractive Linux gaming platform. A more attractive Linux gaming platform means more hardware sales. More hardware sales mean more developers optimizing for Linux. The cycle accelerates. And the foundation under all of it is Linux. Now let's shift to something that doesn't get nearly enough airtime when this conversation happens. Education. Because what happens in classrooms today shapes the computing habits of entire generations. And the classroom, especially in America, has been quietly undergoing a Linux revolution. Chromebooks. You've seen them. Maybe you used one in school or your kids use them. They look like simple, cheap laptops. And in some ways they are. But what most people never think about is what's running underneath Chrome OS. It's Linux. The entire Chrome OS operating system is built on a Linux kernel. Every student tapping away on a Chromebook in a public school is running Linux-powered hardware, often without even knowing it. And the numbers here are staggering. Chromebooks captured a majority of the K-12 education device market in the United States, not a small share, a majority, which means the computing experience that's shaping how millions of young people think about technology, how they interact with computers, how they develop their relationship with digital tools. That experience is fundamentally Linux-powered. Now zoom out beyond American classrooms. Look at the developing world, where national educational technology programs have been deploying Linux-based systems for over a decade. The economic logic is simple and irresistible. When you're building educational infrastructure for millions of students on a constrained budget, a platform with zero licensing costs isn't just attractive. It's the only rational choice. Countries across Africa, South Asia, and Latin America have built entire educational computing infrastructures on Linux-based systems. Think about the long-term implication of this. The generation of students growing up with Linux-powered computing today becomes the workforce of tomorrow. They become the developers, the engineers, the IT decision makers, the executives. Their baseline comfort with Linux-adjacent systems doesn't vanish when they graduate. It compounds. And the enterprises and institutions they build will reflect the computing habits they formed in those early years. But let's move from classrooms to something you probably interact with every single day without realizing it: your car. Modern automobiles are no longer just mechanical machines with a little software bolted on. They're software-defined platforms on wheels. The computer in a modern car manages everything from the engine and transmission to the navigation system, the driver assistance features, the infotainment interface, the climate controls, and increasingly semi-autonomous driving functions. A high-end vehicle today might run more lines of code than the systems that sent Apollo astronauts to the moon. And who's powering that automotive computing infrastructure? The Linux Foundation, through something called the Automotive Grade Linux Project, has been coordinating the development of a vehicle-specific Linux distribution built to meet the demanding safety and reliability requirements of automotive deployment. The membership roster of this consortium reads like a who's who of the global automotive industry: Toyota, Mazda, Subaru, Suzuki, and a growing list of additional manufacturers. You're interacting with a Linux-powered interface. Hundreds of millions of vehicle owners in their daily commutes are having regular computing interactions with Linux. Most of them have absolutely no idea, and that's exactly the point. Linux doesn't need credit to have territory. The autonomous vehicle future makes this even more significant. Real-time sensor fusion, simultaneous perception, and decision-making at highway speeds, the kind of processing reliability that keeps a vehicle from becoming a 2-ton missile, all of this demands computing infrastructure that is stable, auditable, and proven in safety-critical environments. Linux has become the development environment of choice for autonomous vehicle research precisely because it offers those properties, and because the path from development to production deployment is smoother when both environments share the same foundation. Healthcare is where Linux's presence becomes genuinely profound, and where the stakes of getting computing infrastructure right are measured in human lives rather than market share percentages. Think about the medical imaging equipment in any modern hospital: CT scanners, MRI machines, ultrasound workstations. These aren't just expensive hardware. They're complex computing platforms that need to operate with absolute reliability, because a system crash isn't just an inconvenience. It's a patient care disruption that can have real consequences. The FDA's medical device software regulations establish demanding standards for these systems, and Linux's combination of proven stability, open source auditability, and zero licensing cost makes it a natural fit for medical device manufacturers navigating those regulatory requirements. When a radiologist sits down at an imaging workstation to review a CT scan, the software they're looking at is often built on top of a Linux foundation. The interface might be custom, the application might be proprietary, but underneath it all, Linux is providing the stable, secure, reliable ground that patient-critical computing demands. Go deeper into hospital infrastructure and the picture becomes even clearer. Electronic health record systems, laboratory information platforms, pharmacy management software. These are the backbone of modern clinical workflows, and they predominantly run on Linux servers in hospital data centers. The Windows workstation the nurse uses at the bedside is typically connecting to Linux-powered backend systems that hold patient records, manage medication dispensing, and coordinate care across departments. The visible surface is Windows. The invisible foundation is Linux. And then there's the most dramatic validation of Linux's reliability: the applications where failure is simply not an option. SpaceX's Falcon 9 rocket, one of the most successful orbital launch vehicles ever built, runs Linux on its flight computers. Not because it's trendy, not because of ideology, but because when you're managing the ignition sequence of 9 Merlin engines and guiding a booster back to a drone ship landing in the middle of the ocean, you need an operating system that has been battle-tested, that behaves predictably under pressure, and whose codebase can be independently verified. Linux earned that role. The International Space Station runs Linux. When astronauts conduct experiments in microgravity 250 miles above Earth, the computing infrastructure supporting their work runs on Linux. And then there's Ingenuity, the little helicopter that achieved powered flight on Mars. The first aircraft to fly on another planet ran Linux as its flight control system. When that rotorcraft lifted off the Martian surface on April 19, 2021, it was a Linux-powered moment that will be remembered for centuries. United States military branches, The Navy's submarine fleet, Air Force tactical computing systems, Army battlefield management platforms have incorporated Linux into defense computing infrastructure. The security-conscious nature of government procurement means these decisions come after rigorous independent assessment. Linux's open-source architecture actually helps here, because the ability to audit the codebase independently, rather than relying on a vendor's assurances about what's inside a closed system, is an enormous security advantage. The fact that Linux passed those assessments and earned those deployments tells you something fundamental about the platform's credibility. Now, with all of this evidence assembled, gaming, education, automotive, healthcare, space, defense, the natural question becomes, why can't the competition catch up? Why is this trajectory structurally irreversible rather than just a temporary advantage that a sufficiently motivated competitor could close? The answer comes down to 4 interlocking structural realities that reinforce each other in ways that are genuinely difficult to dismantle. The first is the zero licensing cost asymmetry. Linux is free. Not free as in a promotional period, not free as in a limited version, permanently, structurally, architecturally free. This creates a cost comparison that commercial alternatives simply cannot win in any large-scale deployment scenario. When an automotive manufacturer is deciding what operating system to put in millions of vehicles, when a school district is procuring thousands of devices, when a cloud provider is building out server infrastructure at massive scale, the economic advantage of zero licensing cost doesn't just influence the decision. It often determines it. For a commercial platform to overcome this, it would need to fundamentally destroy its own revenue model. That's not a strategic pivot. That's structural self-immolation. The second is network effect multiplication. Linux now sits at the center of interconnected ecosystems that each generate their own momentum. Developers overwhelmingly prefer Linux-based development environments. Cloud infrastructure is predominantly Linux. Educational systems are deploying Linux at scale. Each of these creates pull that attracts more talent, more tooling, more investment, and these network effects compound each other. The developer who learned on Linux in school builds cloud infrastructure on Linux at work, which makes Linux cloud skills more valuable, which attracts more developers to learn Linux. Reversing this would require simultaneously breaking multiple independent network effects, each of which would need to collapse at roughly the same time. The probability of that happening approaches 0. The third is institutional embedding depth. Linux has been running mission-critical infrastructure for decades. Hospital systems depend on it, defense networks depend on it, space programs depend on it, internet infrastructure depends on it. The cost of extracting Linux from these embedded positions isn't just financial, it's operational risk at a scale that institutional decision makers will never voluntarily accept. You don't rip out the operating system running your submarine fleet computing on a whim. You don't migrate your hospital's clinical infrastructure because a competitor has a better marketing campaign. Institutional inertia is a force multiplier for Linux's existing position. The fourth is development velocity asymmetry. Linux development happens through a globally distributed open source model where thousands of contributors, individuals, universities, corporations, research institutions, simultaneously improve the platform. No single commercial competitor can match this aggregate development capacity. Microsoft, Apple, Google, each is a formidable organization, but each is bounded by its own headcount, its own budget, its own quarterly targets. Linux has no such ceiling. The distributed contributor model means the ceiling is essentially the global pool of interested developers. That structural asymmetry doesn't narrow over time, it widens. So here we are. Linux on the desktop, around 3%, Linux everywhere else, the foundation of the modern digital world. Gaming hardware that sold in the millions and flipped the narrative on PC gaming portability, Linux. The classroom computers shaping how an entire generation thinks about technology, Linux. The infotainment system in hundreds of millions of cars worldwide, Linux. The back-end servers running hospital electronic health records, Linux. The flight computers on rockets trusted to deliver satellites and astronauts to orbit, Linux. The Mars helicopter, Linux. The desktop is Windows. Nobody's arguing about that. Windows owns the desktop and will likely continue to own it for the foreseeable future. But the desktop is one domain, and it's not even close to the most important domain anymore. The economy runs on cloud infrastructure. Healthcare depends on networked clinical systems. Transportation is becoming software-defined. Education is shaping the next generation of builders. Space exploration is pushing the boundaries of what computing can achieve in the most demanding environments imaginable. Linux is the ground beneath all of it. The people who look at desktop market share and declare Linux irrelevant are doing something understandable. They're using a familiar metric to answer a familiar question. But the question they're answering is the wrong one. The right question isn't which operating system do people use on their personal computers. The right question is which operating system underlies the most critical, most expansive, most consequential computing happening in the world right now? And the answer to that question isn't even close. Linux isn't taking over. Linux already took over. We're just now starting to use a map accurate enough to see it.